In 6.4, we're going to be talking about quadratic word problems. Basically, we are going to have these quadratic equations that are related. Usually, a lot of times it is for trajectory motion. A rocket is being launched. You're throwing a ball up into the air and it's coming back down. Those are very, very common for quadratic word problems. Many of them will follow a path like we see here. So, if we're standing on the ground and we throw a ball up, usually because of the way the gravity works, it's going to travel in a quadratic sort of motion. A maximum occurs when the a out of the ax squared plus bx plus c of our quadratic is negative. So you will see these rocket problems, these throwing the ball up into the air problems, they will usually start out with a negative x squared of some sort. Now, there are some other quadratic types of problems. Sometimes you might want to find the minimum amount that we have to pay for something, or the minimum amount of material we have to use, or something of that sort. Those parabolas will look like what you see here. And in that case, our ax squared plus bx plus c, the a value has to be positive. So you have to remember, if your x squared term is negative, the parabola is upside down and the vertex is a maximum. If the x squared plus bxc, the ax squared, the x squared term is positive, your parabola will be up, right side up like we see here, and our vertex will be a minimum. So when we were graphing them in 6.1, that vertex was super important. And we found that vertex by doing negative b over 2a. Now, negative b over 2a is where the maximum or minimum happens. It's not necessarily the maximum or minimum value. The maximum or minimum value, you have to actually plug in the x value. So it's f of x. It's the height on the graph, so it's the y value. That's what the max or min is. So if we are looking at a point, the x is negative b over 2a. The y is the function I plug in, negative b over 2a. So you got to ask or think about, what are they asking in the question? If they ask for what time are we at a maximum height, that's your x usually. If they say what is the maximum height, then that is, you have to plug in the x to find what height that happens. Now the best way to do these is to jump in and do some of these. So we're going to, this is the assignment for 6.4. You will see that we've got a mixture of some of the review from the other things, okay? But I would like to, at this time, do some of these together and then leave some of them for you to do on yourself, for yourself. The first ones I want to do is I want to do problem 1 and 2. Now they're completely related. If you take a look, same equation for a fireworks rocket, okay? So let's take a look at problem number 1 and number 2. It says, a fireworks rocket is launched from a hill above a lake. The rocket will fall into the lake after exploding at its maximum height. The rocket's height above the surface of the lake is given by g of x, which is equal to negative 16x squared plus 64x plus 60. What is the maximum height of the rocket? Okay, so the first thing we have to look at is we have to look at the word they used here was maximum height. And this is a parabola with a negative x squared, so we know the maximum occurs at the vertex. So we need to calculate negative b over 2a so that we can find when the maximum is going to happen. Okay? So how do we do that? Well, our a value in this equation is negative 16. That's what's on our x squared. Our b value is 64. That's what's on our x. We're going to plug those in. Negative b, so negative 64, over 2a. So just take your a and double it before you set it in there. And so a is negative 16. If I double it, I get negative 32. So that is at 2 seconds. So at 2 seconds, it's going to reach its maximum height. Now the question said, what is the maximum height? Well, then we have to actually plug 2 seconds in to the height equation, which is the equation you see right here, negative 16x squared plus 64x plus 80. Well, that's going to be negative 16 times 2 squared plus 64 times 2 plus 80. Now please follow your order of operations. So it's going to be negative 16 times 4 plus 64 times 2 plus 80. Following order of operations, you have to square this before you multiply by negative 16. And we get a height of 144. It told us that it was in feet, and you can see the multiple choice there. And so the answer is D, 144 feet. Okay? Now let's take a minute and read the second question about the fireworks rocket. A fireworks rocket is launched from a hill above a lake. The rocket will fall into the lake after exploding at its maximum height. The rocket's height above the surface of the lake is given by g of x. How long will it take the rocket to hit the lake? Well, if they want to know how long it's going to take to hit the lake, what we want to know is where is the height back to 0. So what we're looking for is where is negative 16x squared plus 64x plus 80 equal to 0. Well, that's a quadratic equation that can be solved by factoring or by the quadratic formula. I say let's just jump into the quadratic formula. So remember the quadratic formula. It is the opposite of b plus or minus the square root of b squared. Now I'm just going to square b, save a little room here. That's 4096. Minus 4 times our a value of negative 16 times our c value of 80, which is going to make that a positive, because we're going to have a negative 4 times a times c, which is negative 4 times negative 16 times positive 80, which is positive 5120. All over 2a's. Now a is negative 16, 2 of those is going to be negative 32. Okay. Now, let's think about what that is for a minute. That's going to be negative 64 plus or minus. Now, let's do 4096 plus 5120 is 9,216. And it happens to be a perfect square of 96. So that's plus or minus 96 over negative 32. Okay, now let's do the math. It's just two math equations. Negative 64 plus 96 is a positive divided by a negative. A positive divided by a negative is a negative. We're not going to go backwards in time. So it just so happens we're going to use the negative version this time. Negative 64 minus 96 is negative 160 divided by negative 32 will give us the positive time we're looking for, and the answer is 5 seconds. Okay? Anybody have any questions about 1 or 2? Oh, so the answer is okay. So I want you to try 3 and 4 on your own, 5 and 6 on your own. I want you to try those. Try these word problems. It's a very similar ideas to what we just did. It kind of does look at here. You know, you have to do the souvenir, shipwreck, scuba diving twice. You know, you got to do the superhero. You know, just give them a shot. Now, what I would like to do is I would like to do some of these ones on the bottom we're going to do the odd ones that we see here. Okay, so if you could follow along, let's do the odd problems that you see. For problem 9 and 10, they are asking us to factor completely. Now remember, the first thing you got to do when asked to factor is to look at, is there any numbers that go into everything? Is there a greatest common factor? There is not a number that goes into, for number 9, 6, 23, or 18. So because of that, I'm going to do slide and divide. I'm going to take the 6 over. 6 times 18 is 108. And I'm going to pretend like this problem was a squared minus 23a minus 108. And I'm going to try to factor that. So I need the factors of 108 that subtract and have a difference of 23. Okay. Well, I know 6 and 18 made the number 108, so I can use that to help me. So that would be 9 and 12. 9 times 12 only has a difference of 3, so that doesn't help me too much. Let's see. I always just kind of start mixing things up again. I think the 27 goes into 108. Let me see. 108 divided by 27 is 4. Oh, there we go. We found it. 27 and 4. 27 times 4 makes the 108 and has a difference of 23. So that's going to be a minus the 27 and a plus the 4. Now let's remember why. If the middle sign is negative, we have to have the bigger number match that. Now, we slid over a 6. So let's divide by 6. Now we got to reduce those fractions as much as we can. 27 and 6 are divisible by 3, so that's 9 and 2. 4 and 6 are divisible by 2, so that's 2 and 3. Whatever denominator is left, put it on your A, and we found the answer. So the answer is 2a minus 9 and 3a plus 2. Now, how can you check to see if you got it right? Well, if we got it right, 2a times 3a, the first should multiply to give us 6a squared. The last should multiply to give us negative 8. The inner and outer, so negative 27 plus 4, should give us negative 23. So there is your answer. Okay. Now let's take a look at number 11. Number 11 is about solving this by factoring or using the quadratic formula. Now, if all else fails, if you didn't like what you saw in number 9, we can always solve number 11 and 12 using the quadratic formula. But no matter what, for 11 or 12, you first have to get it equal to 0. So I am going to subtract 26x and add 48 so that this problem equals 0. So this came over and became a negative. This came over and became a positive, and I got it set equal to 0. Now, let's use the quadratic formula. Okay, so the quadratic formula says that x is going to equal negative b plus or minus the square root of b squared minus 4ac all over 2a. Now in this particular one, your a value is stuck on your x squared, your b value is stuck on your x, your c value is the constant all by itself, okay? Now we got to just plop into the formula. You have to follow order of operations or it's not going to work. So x is going to be equal to the opposite of b plus or minus the square root of b squared. Now when we square negative 26, when we square anything in this spot, we're always going to get a positive. So negative 26 squared is positive 676. And now I just like to do that. Negative 4 times a times c. So negative 4 times 3 times 48. I get negative 576 all over 2a's. Now a was 3, so just double it. So I get 26 plus or minus the square root of 100 over 6. Now square root of 100 is a thing. It's 10. So that's 26 plus 10 over 6. And then you just have two little math problems to do. 26 plus 10 is 36 divided by 6. 26 minus 10 is 16 divided by 6. Reduce them. Well, 36 divided by 6 is 6. That's great. 16 divided by 6 is not perfect, but they're both divisible by 2 and make that 8 over 3. Okay? And then you're going to use the same formula for number 12 and 13 and 14. My key is, remember, it's got to be in descending order. Ax squared plus bx plus c. It's got to be equal to 0. So for 12, you got to move those to the other side. 13, move the 15. 14, move the 5n. And then finally, I want to take a look at number 15. So it says for each function, determine if it opens up or down, find the vertex, graph the function, determine if it has a maximum or minimum, and what that value is. So because our a value is -2, that means that our parabola is going downward, and so that means that that it has a maximum. Okay, so by just looking at this front number, if it's negative, it's opening up downward, and we have a maximum. So we can answer A and part of D. Okay. Now I'm not going to do 16 for you. I want you to do that one yourself. But since its A value is 2, it's going to be opening like that. So it's going to be opening up, and it's going to be a minimum. Okay. Now let's continue with number 15. Now the next thing you want to do is find the vertex. So we're going to do -b over 2a. So our b value is 12, so take the opposite of that, and then double a. A is -2, so double that's -4 or 3. So I know that the vertex is 3 something, but 3 what? Well, we're going to have to plug in 3. So we get -2 times 4, or -2 times 9, I'm sorry, is -18, plus 36 minus 15. All I did was plug in 3. So we get a value of 3. So our vertex is at 3, 3. Now to actually graph it, we need to plug in 3. We definitely need to plug in at least one thing to the left of that and one thing to the right of that. So let's plug in 2. -2 times 2 squared plus 12 times 2 minus 15 is 1. Okay, now let's plot those points. Okay, so that's C is the graph. So, what do we got? So at 2, we are at 1. At 3, we are at 3. At 4, we are at 1. So our graph looks something like that. Now let's see if we've answered all the question. We set it open down for part A. B, we found the vertex was 3, 3. C, we graphed it. D, determine if it's a max or min and what is the value. So we determined it was a max, and then for the value, just put f of 3 equals 3, because that tells me that the x value was 3 and that the maximum is also 3. This right here is the max. Any questions on 15? Okay.